Hi, and welcome to part 4, or I think it's part 5 of the chucK granular tutorial. We're going to, in this, simply move the position forward of our read head. Okay, so theoretically, if you imagine you're having your grains read from some part of your samples, well, right now the way we have it set is we have it read a position, a random position, somewhere from the beginning of the sample to the end of the sample. So right now I think I'm using this glass break sample right now. And so it's reading for my grain, it's reading somewhere randomly between the beginning of my sample and the end of my sample. Now if we want to move it forward as we would normally, as you read, you're going to kind of move this as like a read head forward, and then the granulator will take grains from wherever that read head is. So you might have several grains read from the same place, but this way you can move it forward a little bit. Okay, so let's start by making the new position, new posts variable a global one. So we'll just have we'll set it to 0. That'll be our starting position. Okay, and then here in our read position, we're going to just do a little bit of math. Basically, we want to take the 0, right, the new position, and then we want to make it equal to, new position plus some amount of milliseconds, say 15 ms, something like that. Okay, so this is like the pseudocode. So basically, every time a new grain gets generated, it moves the read position ahead 15 milliseconds. Okay, so this needs to be expressed in number of samples, and then we have to chucK it instead of equal. This is just the old way. So we have to think about the new position, which is 0, and then adding a certain number of samples, because that's what the position, eventually it's going down to our position. It's getting chucKed to our buff position, right? That's the playback position. So it's going to need to be in samples, all right, because that's read in samples. All right, so we're going to say new position. We're going to say we have to reverse this, unfortunately. All this chucKed to the new POS, right? And that's chucKed. So the right side's taken care of. We're going to chucK that to new position. So we're going to have new position, and we're going to add something now. So we have to calculate a certain amount of milliseconds in samples. So let's say we want to move forward like 15 milliseconds every time. Okay. So what we're going to do is we're going to actually not do it that way, because this is an integer, so we have to convert it to an integer. So first thing, we're going to convert it to a float. Now chucK is a little interesting this way. So if I print out ms, that's going to be the number of samples in 1 millisecond. Okay, so if I just do that, and I start my virtual machine, I add my shred, you notice that the data type is dur. This is the data type that chucK has, the duration. It also has a time. I'm not sure if there's a difference between the time data type and the dur data type, but it comes up as milliseconds. Now if I do some kind of mathematical operation, say samp, so this is the number of samples in a millisecond, but it's a duration. And if I divide it by samp, which is another duration, let's just verify that. I think samp is a duration. It could be something different. Yeah, it's 1. That's 1 sample. That's how many samples per sample, which is 1. ms. So if I do the amount of milliseconds divided by sample, it comes to be a float. Okay, so you just have to express it this way. Milliseconds divided by sample will give you a float that is equal to the number of samples in a millisecond. All right, so we're going to take the number of samples in a millisecond, which again is ms divided by samp. That's the number of samples in 1 millisecond. Number of samples in 1 millisecond, and then we're just going to multiply it by the number of milliseconds that we want to move forward. So in this case, if we want to move forward 15 milliseconds every grain, that's going to move our read position forward 15 milliseconds. It'll convert it to the number of samples, right? And then we just add that to the previous new position to keep moving forward like that. Okay. Now, one final thing we have to do is we have to take this whole thing, and it's going to become a float. The new position plus this floating point number is going to convert it to a float. So we have to cast this whole thing into an integer. Okay, so we're going to take that, another parentheses. I hope I'm doing the parentheses right. And then we're going to do a casting thing, which in chucK is the $, and we're going to cast that into an int. Okay, so all this does is converts this number, and you can even make it a variable if you want, but this number, the number of milliseconds, it's just going to move the read head forward that many milliseconds every grain. Okay, so if we if we just listen to it without the new thing we did, and that's with a random reposition. Okay, if we move it forward 15 milliseconds every grain, it sounds like this. So it's reading through pretty quickly. So this is going to depend on the duration of the grain and the gap of the grain. So depending on how often you do this, it's going to move forward every 15 milliseconds every time. There's a more complicated way to move it forward, like precisely in one time or two times, but it's kind of out of the scope of this tutorial. So let's move it ahead just a few. So depending on what you change here, you're going to have to adjust this number along with it, which is kind of fun to do anyway too. So let's just make it 5. Let's see how that sounds. That's kind of interesting. And then if you want to do something that it's kind of like a time stretch or something like that, you'll just make the grain deer quite long. Let's make it 300 to 700, and then the gap quite short. We'll make it something like 5 to 15, maybe something like that. Okay, and then you'll probably have to move this up a little bit. Let's try it at 15. What happens? Oh, right, because the gap's really short. Okay, so this means it goes quite fast. So let's just make that like 50 maybe, and then we'll make it like 150 like that. Let's see what that sounds like. And of course, you can move this number down if you want. Anyways, in a later tutorial, I'll have a more mess around one, but you get the idea. You just kind of adjust this in terms of the grain duration, grain gap. All right, so that'll do it for this one. This is just to move the position forward, doing a little math, and you can move the position forward while you do your granular synthesis on it.